Alright, so begins another draft physics video presentation. Was going to do a couple of subjects, but I don't know. So we're going to talk some about a video by 60 Symbols, where they actually start talking about some of the wooey ideas that their physics has allowed to be believed by people as fact, just because, yeah, like I said, the physicists have given people every reason to run with the ball they created, the ball of woo, and so they certainly get what they deserve in the sense of bizarre abstractions, and but they don't take any account for the fact that they still have a bunch of axioms or fundamental beliefs that are nonsense, like the Heisenberg principle, which, I was listening to a Hawkins book, and it's being used for all kinds of things. Like there's no, nothing can ever be in a quiet state in the universe based on the Heisenberg principle, because somehow you could detect its velocity and its position, both, and so it can't possibly have neither. It can't possibly have a stable velocity and a stable position, merely because, well, if it did, then we could detect it, and we could detect both, and can't do that. So everything has to have quantum fluctuation. So anyway, it's the reasoning is so bad in the sense that the evidence is so bad. So anyway, first, I'll do a little bit on gravitational lensing, because I thought of another problem with the conventional notions. It's worthy of some conversation, I would say. I guess I should click on this just so I'm still in the picture somewhere. Not that it really matters. Alright, so the lens idea. Something that's important that lenses do that, is sort of underappreciated. It's not so much about this angle and this angle, It's more about the fact, so you're taking something small and essentially making an image of it that's really big, okay, in the lens. The key thing is that what it's really doing, okay, that's really important, it's restoring the phase of the light that goes through the lens. Because this light travels a longer distance, you can sort of understand that unless the object's dead still, the light going this way is not going to be the same as the light going this way in terms of time. So in the same amount of time, this light only gets to there, doesn't even get to the lens. And so what the lens is doing, because it takes time for the light to transmit through the lens, a key thing the lens is doing is it's adding time to the stuff going straight, and it's subtracting time essentially from the stuff that went to the outside of the lens. It goes through less of the lens, it gets slowed down less, and therefore when the two beams come back out, now they're back in phase. They were knocked out of phase by going different directions. That just kept killing their phase. The phase would end up out of phase. And now you're restoring not only the phase, but sort of the ray length. I mean, the rays are now back in the same timing. And so the image is coherent because of that. You have an image. And if you don't have that, then, if I made this out of air inside of here, I can put something over here and not see it at all. There won't be any image. It won't get through because I've broken the coherency of the rays and therefore ruined their phase and ruined any ability to reconstruct the photons. It's sort of important. So, and the idea is that gravitational lensing is depending on restoring light that has a different path length. I mean, obviously the path length for the light going here and the light going over here, these are huge path length differences. No matter what the distance is, even if I have two slightly converging lines, I mean, it's only a tiny angle it doesn't matter. With every bit of increase in distance, I am increasing the amount they're out of phase, the amount one is behind the other in time. And there's nothing in the gravity lens. There's no, what do they call that constant? Reflective index in space. The space isn't glass. Okay, it can't compensate for the time difference between the light traveling from one portion of an object from the other portion. The distances are different, and so your image is going to be, this is 6 years ago, over here, this photon, and this photon is 17 years ago. There won't be photons that are anywhere close to the same age. And so even if you think the photon is a solid thing that doesn't need reconstruction, you can just understand that it's less likely you're going to have anything called a coherent image if some of the light's coming from 17 years ago when the object was over here, and some of the light has come from something that was 6 years ago. Not going to work. Can't possibly do anything coherent in terms of constructing an image, and not likely, more so if you kind of understand that the light's in little pieces, and the pieces are what gets constructed into a photon. So the light is more than it really looks like, because there's a lot of pieces that don't get rebuilt. But anyway, so the point is and there's still got this huge problem that the path lengths, the gravity lens bends the light that needs less bending more, and bends the light that needs more bending less. And obviously that's not a focus. The focus would be here. Gravity can't really work to focus, to take the big image that you've cast in the big giant space of the lens and project it to single point. It can't do that because it needs to bend this stuff less and this stuff more, and it's going to do exactly the opposite. So just pointing out, that's another aspect of the brokenness. Not only is the lens the wrong shape, the lens doesn't have any density, and it needs that density to restore the broken time. All right. So we'll go do some of this video and such. So he's reading a daily something or other, daily news article or something. Now, I've pointed out that the Dr. Quantum video is the most viewed physics video on the internet. Probably dozens of millions of views with the different versions of it. And it's just such garbage. Is he going to attack that? Yeah, no.
Right, now this, Brady sent me a link to this, and it combines all my worst, bugbears, all of the things that really irritate me.
Right. So I have the same feeling about all your woo. I mean, you're silly, we never even redone the Eddington experiment. Never redone a 100-year-old experiment, okay, with new technology. Even the best eclipse you could possibly have over the most advanced country in the world, and some amateur guy did it with a bunch of synthetic crap, not even doing it the way Eddington did it. And that's it. Never done it from a satellite. Thousands of satellites up there. Never tried to do the Eddington experiment, which you could do any day, anytime you want to. So why don't you explain how your own physics, the physics you're so devoted to, isn't just as much a pile of woo?
My gears get under my skin.
Yes.
First of all, it's the Daily Mail.
That's why I sent it to you.
I know. It's the Daily Mail, which is a bastion of reactionary writing.
Yes, well, right, and the bastions of left-wing crapola are just as bad, frankly. Why is the volume inadequate here? They should have better volume. Yes, they should. I think I have this all the way up. Yeah, pretty much. Launch player. I don't want to do that. Sound settings. I'll go up a little higher. See what we get.
Centre news and storytelling in the UK. The UK would be a hell of a lot better. Britain would be a hell of a lot better if we didn't have a Daily Mail. That's the first thing. Then it's combined with, as you can see, quantum physics proves that there is an afterlife, and claims like one expert claims he has evidence to confirm an existence beyond the grave, and it lies in quantum physics. So now we're getting into the area of quantum physics woo, and the whole idea that, there's a fantastical element to quantum mechanics. We're all one part of one integrated, interconnected.
Yeah, that's right. And haven't all your physicists do exactly that? They imply that maybe consciousness has something to do with it. The Al-Kahari guy implies that our whole biology is quantum. Our brain is quantum. So your own club is causing the effect. So clean up your own house. Why don't you find some of your colleagues and point out how they're full of shite? Why don't you have the guts to actually do that instead of playing with, yes, the crazy little holistic wackos or the free energy wackos? So this is just like, they pick on the flat earth, but, they won't go after other physicists. This is the sacred ground.
The weird and wacky and wonderful stuff that happens right down at the atomic and molecular level, and weird and wacky and wonderful stuff does.
Yeah, yes, it's all weird, wacky, and wonderful. Aren't you doing the same thing? Wonderful. What kind of adjective is that for a scientist to use? Oh, it's so wonderful. I mean, it's just such a jargon. Weird and wacky. Yeah, you ought to consider that. You ought to sit there for a minute and say, what weird? It really shouldn't be weird and wacky. It's the physical reality. I should be able to explain it, as Newton would say, or Einstein would say. You really should be able to draw a picture of this crap, and you can't. Your Heisenberg nonsense, Heisenberg principle. Well, you've obviously made it the Heisenberg law, that there's some kind of law that says, no object in the universe, can be understood as having a set trajectory and a set velocity.
Up and down there, somehow magically transmute, so magically you can scale up to the real world. So we've got all these fascinating effects happening on sort of everyday length scales. It's really frustrating because this doesn't.
Well, you do that though. You imply it with you sit there and say the two-slit experiment works with buckyballs. You'll say something where it's kind of just overtly preposterous to make that argument, that it's the same effect, that anything that goes through these slits will have this effect take place, when, in physical fact it doesn't. Okay, that the amount of effect diminishes substantially. And why? Because the electron is a fixed size, and that's what you're really hitting when you're going through those slits, is you're hitting electrons. That's the cause of the effect, and once you're big enough, the electron can't bother you anymore. And that's the simple truth. That's why you don't see it in the big world, is because the electrons become quite irrelevant, because they're tiny compared to the mass you're throwing through.
To be new stuff. I don't quite know why this has suddenly come to the fore, but it's this guy called Robert Lanza. Now, Robert Lanza, he's obviously a very clever guy. He's done a lot of really neat work in stem cell research, it seems. I'm not a stem cell researcher, so I haven't read his work in detail. But what I do know is that he's got no background in physics. And of course, the usual argument is, well, that means that's great, because he's coming from left field. He can throw all the establishment ideas away, and he'll come up with these radical new ideas.
Yeah, well, it's a legitimate argument, because you're doing exactly what the establishments always do, right? Which is ivory tower yourselves. You're protecting yourself from any kind of challenge, okay? You'll just call everybody a wacko or a fake or a phony or a liar or an idiot. And you'll see in your own, like I said, in your own ivory tower, you're too afraid to push people out the window. You're too afraid to clean your own house.
That's sort of like me going, well, I've absolutely no background in surgery, but I'll tell you what, I'm going to go in, I'm going to get in there at the operating table, I'm going to develop some really new techniques. Oh dear, I've made a mess.
Yeah, wait a minute. Yeah, that's not all that illogical, is it? Because it's mechanical, the process, and there's, just like physics, it's understanding a few of the basic laws or rules. And the point I've just made is that you have established a bunch of ideas or notions, and you've converted them into laws without any scrutiny or any kind of real evidence, like gravitational lensing. You just don't care that the math really doesn't work for all the galactic images, and you just don't care that you've never really done the Eddington experiment with any integrity, and you just don't care.
Yes, it's the argument that left of field ideas can come from very different places than you might expect. That's true. But we're not gonna. I'm not gonna accept that it's true, because I'm not gonna look for it. I mean,
Brady has to show up with the wacky article and hand it to you and force you to deal with it because you don't want to deal with it on your own. What, you don't ever watch the internet and see what the hell physics is being taught, what kind of nonsense is being said? Yeah, I'm supposed to believe that. No, you just don't care.
What's the quote? Fortune favors the prepared mind. You know, there has to be...
Fortune favors the prepared mind. Well, that's just wonderful. I like Pasteur, but, you know, that's not much of a statement. I mean, it sort of makes sense in the sense that, you know, Pasteur was pointing out the obvious, right? Nobody paid attention to the obvious. Oh, you know, there's these little things called bacteria, and you really shouldn't stick them into open wounds.
Some level of background there. You've got to think about what the history of the field has been. You've got to try and work your way through. And what he's basically saying is actually not that much different from a book called The Tao of Physics. Very famous book. It's been out there now, I guess, since the 70s. I can't quite remember, maybe even the 60s. And what...
Yeah. Why don't you just watch YouTube and find the Dr. Quantum video and just see where they're taking your physics. And they take it with the same lies your own physicists tell. Oh, we've done these detector experiments. There's no detector experiment anywhere. There's no evidence you ever did it. Even the single photon experiments. I mean, the French guy did it, whatever, almost 100 years ago, I guess. And who's repeating it in the same way he did it? Oh, probably no one. I mean, you know, you have better technology and more money, and yet you don't do any of this fundamental physics. I mean, all of the stuff that, you know, you've based the whole thing, you've built it on this foundation, and you haven't checked any of those foundational stones to see if they're really made out of anything, like your silly Heisenberg principle.
What it does is it connects New Age ideas, sort of Eastern mysticism, with quantum mechanics and quantum physics. The idea that, you know, quantum physics means that there's an interconnectedness to all things, and with there's a...
Well, I mean, you're stepping right into it. You sit there and tell us these particles are magically entangled, okay, and it's by some mechanism that's instantaneous. It might as well be because it's something above the speed of light. And what are you claiming it based on? Alan Aspect's bullshit experiment, right? I mean, the bullshit magic beam splitter again, and polarization film. Like you actually know how polarization films work. Like you actually know what you should expect, and like anybody's even tested it. You can't find anywhere an experiment where somebody measures how hot the polarizing film gets. It's blocking light. Well, if it's absorbing it, it should be heating up. If it's reflecting it, the energy should be going somewhere. Has anybody ever done any experiments to see? No. I mean, you want to believe the woo, clearly, because you're aggressively cheating the real evidence.
Universal spirit, all these type of things.
Well, it is ESP. Frankly, you can't get around it. And you're basically saying all this stuff exists, right? You're saying there's a bunch of antiparticles. Where the hell are they? Where's their mass? Oh, they don't have any mass. They're just magically massive. I mean, it doesn't make any sense, the crap you're saying. There's all of these stuff, 400 kinds of particles inside of an atom, and you don't have a diagram of what the hell they're doing in there. What are they doing? Where are they? How come they only show up in an accelerator? They just magically poof into existence. That's something you believe. You believe space just sits there and just poofs particles. And then the particles annihilate and disappear again, and it poofs them someplace else by some magical poofs theory. I mean, your physics is full of this crap. You're feeding them. You're saying to them, go believe it. Look, oh yeah, we don't have ESP, but our neurons do because they're quantum objects doing electricity. Woo, 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 woo. And therefore, we do have ESP because our quantum little bits do.
Deeply frustrating because quantum physics really says no such thing at all. And what Lanza's done is he's gone a little bit further, and he's basically taken the old idea of the observer affecting a measurement, or the observer affecting an object, to say that actually there is no objective reality out there. There is no universe out there. It's our consciousness. It's our
Again, you're the one saying that. You're the one pretending it's random. Okay, you've accepted your Feynman theory that it doesn't matter where the photon goes in. It's always just a random equation, and forget it. We'll just generalize about the entire 1 million group. I mean, your whole physics is based on some notion that it doesn't matter what's happening to anything individually, because we're just going to classify it as a wave function. And the wave is made out of a million of something. So by saying everything's a wave, you're just saying there are no individual soldiers. Individual soldiers don't have to actually walk across the battlefield, actually climb over the fence, and actually do all this stuff. You're saying, no, it's some sort of wave function, and it's just random. The soldier doesn't actually do anything. He's in a superposition with 1 million other soldiers, and none of them are doing anything individually. I mean, that's your theory. Ugh. Stupid.
Biochemistry that creates the universe. I need a bit of deep breath because it is frustrating. How can I put it? Awful lot of nonsense in this.
Let's be sympathetic for a minute. What has the world of quantum mechanics and physicists done wrong that allows people to start making these connections that you think are spurious?
That's a really great question.
Yes, and the answer to the question is you've jumped the evidence everywhere you possibly can to accept extraordinary conclusions rather than the ordinary conclusion. In every case, you're trying to say Newton wasn't right about anything. In every case, you're trying to make it seem like it's much more complicated than it really is, that the small universe is this insanely complicated place with battleships that have radar and all these instrumentality. All these little bits have all these capacities that we don't have. You know, they are full of Superman superpowers. You know, they can superimpose and be in 3 places or 5 places or a million places at one time. They don't have to actually be anything. That's your physics.
I think I'm as guilty of this as everyone else. Because when you're down at the atomic, molecular, single particle level, weird things do happen. Things that we don't...
Okay, yeah, you don't understand them, and they're not all that weird. I mean, frankly, an on-off pattern isn't that extraordinary, okay? I mean, it's really not that incredibly bizarre. And it's sort of, like I said, you could simply dissect it and say, well, yeah, there's some kind of right-left thing happening or a little bit of an up-down thing happening. Again, even the motor force isn't that complicated, right? You have something going this way and you have something going, well, presumably this way, but its magnetic field's not going anywhere. And then something happens going this way. And you go, no, it's not that incredible. It's just a left turn, you know. It's not that big a deal. But you make it into some sort of extraordinary Heisenberg mystery superposition thingy.
Understand it. Because we don't understand them doesn't mean we can just make up any nonsense. We can't.
Yes, that's exactly what you don't think Ben space is any nonsense. I mean, it's a complete non-answer to the question. What's making the thing move? Well, how's it move? Well, it's moving based on the atoms inside of it. Because I put an atom outside of the Earth, it goes exactly the same speed as the Earth, and they both orbit the sun, and you know, it's the same thing. So yes, obviously it's just the little bits that are being affected by this gravity thing. It's a nuclear force of some kind, a nuclear event of some kind. And instead you've turned it into some sort of, the space is doing it. The space is somehow tilted, or the space is somehow pulling. I mean, your answer is silly. I mean, it's a silly answer to the question, what causes it to move? It's a silly answer.
Just say, right, we don't understand some aspect of quantum mechanics, and then, I don't know, that's because invisible pixies, which are undetectable.
Yeah, virtual photons. So you come up with a stupid answer like, well, I know there's something being communicated between the objects because it takes it time to communicate the message. The message takes it time to get from one plate to the other plate, or one balloon to the other balloon, or whatever the case may be. And you know it takes the same time a photon takes, and so then you call it a virtual photon. That's your stupid, vacuous, nothing answer, is to say, well, we're just going to make up something that, well, yeah, it makes it come towards me 1 minute, and the next minute makes it go away from me by the magical come towards me or go away from me thingies. The spin of the electron, the thing you know has to be negatively charged. You know it's not a dipole, and yet you turned it into one. Why? Oh, because I have to somehow make come to me powers, and I have to make go away from me powers. I have to have the same gun do that. Why do you have to have the same gun? Why don't you have 2 separate guns? The simple answer, right? You have 2 effects, right? You shoot something and it comes towards you, and then you shoot something and it goes away from you. why would you think the same gun does that?
It's also popping in and out of existence and affecting the forces between these particles. We don't have a license to just make up Bohr. Problem is,
Yeah, well, of course you do. You got the license from Bohr. I think you've even described the circumstance where, Einstein presents the perfectly rational dead cat argument, and he gets back from Bohr a bunch of crap, and you say Bohr wins. Why? Oh, well, that's right. No good reason except you want to believe.
all the weird and wacky stuff that happens at the atomic molecular level, like particles at this.
So weird and wacky again. They just keep saying weird and wacky when what really happens isn't that weird and wacky. It really isn't that crazy. Okay? It's just a little bit different than you thought it was, and you have to do a little bit of inquiry to see why there's a difference. I mean, and it's really bizarre to inquire that surfaces, when you go right by a surface, that's a complex medium. You know, that the difference between my skin and the air is, it's not like all skin on this side and all air on that side. You as a physicist know that's not really how it works. And yet you're sending something through that condition and then you're surprised. Hey, it's weird. It's affected. It does something different when it goes through that surface. That medium.
Dual or schizophrenic character where they have behave like waves. You know, we haven't got to the bottom of it.
Behave like waves. So again, it's perfectly rational to understand that soldiers could behave like waves. It's perfectly rational to think that bullets can behave like waves. It's perfectly rational to think cannonballs can behave like waves, right? If all the boats shoot the cannonball at the same time, big wave of cannonballs. It's perfectly reasonable to understand that something that's made out of elements can behave like a wave. I'm quite sure this guy knows that individual atoms create water waves. That individual atoms are actually banging into each other, okay, exchanging pressure, motion, compressing, and that's why there's a water wave created. That individual water molecules are doing it, and they're not in any superposition. I mean, this water molecule isn't the same as that water molecule isn't the same as that one, and I think he knows that. So why is he pretending that on the atomic level something completely different happens? A wave is completely different.
We really don't understand what's going on there. In particular, something called quantum entanglement, where, you know, which Lanza describes at length, and he's right in that it is weird and it is strange.
Yes, no, it's not weird and strange. What's weird and strange is that you drew a conclusion based on crappy evidence. Okay, a statistical aberration, a tiny little statistical difference, and that difference could be completely blamed on the fact that you have made assumptions about how polarization works, and your assumptions are completely untested in the sense I can't find any evidence that you ever did any real inquiry into what exactly a piece of polarizing film is doing to the photons. And the fact is that I'll give this analogy. I've done it about 100 times. I mean, jail bars and throwing frisbees through them. I can go in with the assumption that it's 50-50, right? If I throw the frisbee lengthwise, it goes through the bars. If I throw it this way, it doesn't get through the bars. And I could have the assumption that it's 50-50. And then I could think about it for a while, and I'd say, yeah, every single one I throw this way can't get through the bars. But every now and then, one of the ones I throw this way hits the bar and doesn't get through. So it's not 50-50. So should I be surprised that when I do my experiment based on that wrong assumption of 50-50, and I do my experiment, I don't get 50-50? Oh, big surprise, right? No, it's not a big surprise. I mean, your evidence is pathetically weak, and you should just concede that you're jumping it. You're going way, way past what the evidence can tell you. And you're going past in the extraordinary direction. You're not going past in some ordinary direction. You're going past to justify extraordinary conclusions, like entanglement. It's an extraordinary statement, and it should be proven with really hard, good evidence. And you don't have any.
In that you get two particles you couple them together in some weird state. It's called an entangled state. I'm not going to go into details for this.
Right, because if you went into the details, you'd have to concede that the evidence is so thin, and that Einstein could be perfectly correct in making the simple argument that you created two particles, left and right hands. All right, and you know that if one's a left hand, that you know the right hand glove's over there. You know that there's a matching pair. All right, and that's all there is. There's no entanglement. None of these guys get to decide what they are. They're left and they're right, and they'll go in different places, and they're still left and right, and that's the way it is. And instead you said that can't be possible because Alan Aspect did an experiment way beyond his capacity with his magical beam splitter again and his magical polarizing film.
Physicists among you know.
And another experiment that I haven't seen anybody redo in any substantial way. Every time you do it and they really analyze it, right, they claim they had two entangled particles, one in France and one in England, and it blah, 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 blah. And then they found out, no, it's a bullshit experiment.
You know, it's all about spin and all that type of thing. But you couple them in some state called an entangled state. That's all we need to go into. You send one particle to one end of the universe if the universe is ends, the other particle to the other end of the universe. You make a measurement on this one, and here's the weird bit, the bit that causes so many physicists so many sleepless nights, is that you make a measurement on this one, and this one responds instantaneously. Right.
And again, what is your evidence that that's really what's happening? Your evidence is incredibly dependent on you having complete confidence in all the assumptions you've made about all the details in your experiment, how well you can measure, whether you can detect a photon here and then detect the same photon over here. I mean, all kinds of notions you have in your head about what's really happening in the real physical universe. And if all of those assumptions are 100% correct, okay, then you can have some confidence in the experiment. But you should have no confidence that all of those assumptions are correct.
At the speed of light, instantaneously. There's clearly something, that we're lacking there. We don't understand it. It's a remarkable fact. But
it's an extraordinary claim, and you have less than ordinary evidence. That's a simple, true statement. Why don't you just admit it? Yes, our evidence is less than ordinary. I mean, it's less than what it needs to be. Even if I was making a claim that this chalk is white, I probably need more evidence than they have for this extraordinary claim.
Physicists work extremely hard to try and see these effects, like ultra-high vacuums and very, very, very low temperatures. Those type of effects do not scale up to the macroscopic world. The reason all this quantum weirdness, we don't see it in the macroscopic world. I don't diffract like a wave when I go through a door. Brady is a fairly solid object in front of me. It doesn't seem to have wave-like characteristics at all.
But the laws of probability would argue that you should even be able to figure out by the laws of probability there are so many permutations that we should actually see the totally impossible. And that is, a statue is sitting there going like this, and all of a sudden it goes like this. Just because of the permutations, the amount of experiments the universe is doing with your little quantum fairies. Every now and then the fairies should all end up in the same place by just circumstance, a big pile of total fairy, and the little fairies should do something. And so your own theory it's completely unsatisfactory to say that you can do this quantum thing and then say, well, yeah, when the dice are rolling on the table, the quantum effects all balance out okay, and the impossible can't happen. When it does. It would if your quantum crap was controlling the experiment, but it's not, because it's not a real description of reality. It's right and left gloves. Grow up. Smell the poo.
That's because ultimately it's because we interact with our environment, and that doesn't require consciousness. It's just, it's just the very fact that these quantum waves are getting scattered of objects. That's enough.
All right, these quantum waves, so these entangled soldiers that aren't really soldiers, and they're just morphish ghosts, and they don't become soldiers till you actually kill one. I mean, that's how silly this story is.
You don't need a consciousness to be an observer, and that's one of the difficulties with this, is the sort of anthropomorphic aspect of this is that you're assuming that.
So again, the whole idea of even having an observer is bullshit, because who's going to do the observing? Oh, another quantum entangled, superimposed piece of crap. So you're going to look at the virtual photon with the virtual camera. I mean, you can't even use the word, that you're going to do an observation, because you can't make an observer, because nothing's real now, because everything's in a superimposed state. So you're taking a superimposing camera to look at something superimposed. It makes no logical sense.
Nature, that reality has to be observed by a conscious observer to create this stuff. To come back to your question, Grady, which is a great question, to be fair, we're so desperate to put across, look at how weird and wonderful this stuff is.
All right, weird and wonderful again. You did it again. Weird and wonderful. You think there's something wonderful about these preposterously silly explanations, that time isn't a real function, that it's some sort of location, it's some dimensionality. All right, and that the dimension warps and bends and twists, and I mean, these aren't rational descriptions that are wonderful. They're incredibly obnoxious to anybody a little bit logical, I would think. I'm sorry, I've never found them. Oh, that's so wonderfully wonderful. The wonderful silly answer. I just love silly answers. I mean, you might as well just be talking about angels and what kind of bra and panties they wear or something. I mean, you could make it a little bit interesting, but it's just too stupid.
It's fascinating, and it is fascinating. But the difficulty is that sometimes that's misinterpreted. And quite how we get beyond that, quite how we maintain that, look at how exciting this is, and yet get across the, well, actually...
So again, he doesn't have the courage to take the Al-Kahari guy and point out he's the one talking that shit. He's the one selling quantum biology and quantum, consciousness and all this crap. So your own colleagues are doing it. You can't blame it on some neuroscience guy who's gone a little bit buggy because he doesn't really know how it works. Your own physicists are talking this crap.
You've got to be very careful before you extend this to larger scales.
Physicists are very guilty, for various reasons, of borrowing language from the macroscopic world to describe this world, don't they? We talk about colours and flavours of quarks, and you borrow all this language.
Yeah, right. Even the spin argument. It's not a real spin. It's just some magical property that we call spin. So it's the property of entangleability. Whatever.
People understand.
Yeah, and then it's misinterpreted. Yeah, I agree. Quark is actually a pretty good one, because I would argue that's a otherworldly word. It doesn't connect really to the world around us. Colour is a problem, but one of the things...
spin is a problem.
Spin is a big problem, because spin is not spin. That's the difficulty. It's not spin as we think it, because if you do the calculation, it turns out that if spin at the quantum level was actually spin, things would be spinning around at so many times the speed of light. So
yeah, well, again, by the assumptions you've made, that's the rule. Like you say things like, well, if it wasn't for quantum bullshit, electrons would fall into protons. When you should be saying right from the start, well, where the hell did the energy come from for the electron to be buzzing around the atom at 400,000 miles an hour or whatever it is? And how the hell does it make a figure eight pattern between two things and make that a strong bond?
it is a problem. Thank you, Grady, and we didn't even prepare this at all. So I've been reading this. This is probably the exclusion principle, which...
Yeah, see, another pile of crap. So this is another principle they turned into a law. I mean, they've just turned it into a law. It's not a principle anymore. It's some sort of Pauli law thingy. Exclusion law, which is just more of this rubbish that somehow they've proven hidden variables can't be controlling anything.
It's remarkable. You can see it's the origin and validation of a scientific principle. And this principle, I'm not going to go into it, but it's to do with spin, and actually without this principle we wouldn't have a periodic table. But it's absolutely remarkable, because Pauli didn't introduce...
See, just more horse shit. I mean, it's just horse shit. That these extra properties that they've given electrons and protons are essential to the periodic table. I mean, that's like him saying quantum bullshit invented the transistor. It didn't.
used it as spin. He called it something I translated vaguely from the German, something along the lines of a two-valued electron thing. And that eventually became spin.
It became the dipole. So again, they know it's an electric monopole. They know it's charged, all charged, one kind of charge. It's not a dipole. And yet they've made it a magnetic dipole. It's completely illogical.
It's not quite spin. It's definitely not spin. I think most physicists would think of it as it's a property of an electron, and we label it as plus or minus a half. But actually, what it physically represents is something very, very different.
No, what it physically represents is your effort to sit there and fix your broken assumptions. So you have a broken assumption that it's push and pull, okay? And so you're trying to make push and pull somewhere. You're trying to make something that can do this push-pull thing. So you've decided to give the electron two sides. You know, it's pull side and it's push side. And that's all. That's all you've done. You've just contrived a place to put your special ray gun that does the special reversal thing. But it's stupid. It's a silly imagined solution that really isn't a solution.
Lanza, it basically exploits that, I would say. There's another line in this Daily Mail article. Lanza uses the example of the way we perceive the world around us. A person sees a blue sky and is told that the colour they are seeing is blue, but the cells in a person's brain can be changed to make the sky look green or red. Yeah, okay, that's
yeah, your brain can interpret it any way it wants to, but it can't change the frequency, for fuck's sake. So all of these silly arguments that somehow it can change the light. It can't change the fact that the light had a specific frequency. Yes, you can see green as blue. Your brain could see, you could be seeing, black as red. Who knows? It doesn't really matter, because the only part that we're really talking about is the frequency. Well, obviously there's no frequency for black.
Fine, I'm not an expert in biochemistry, but yeah, I can see how that might be the case. But that's like arguing that there isn't an objective colour there. But we can measure an objective colour because we know the wavelength, or we can measure the wavelength of the light. Our brains might perceive that as red or green.
Exactly. Okay, so he's making my point for me, but yes. I mean, it is a silly semantical game that people play where they want to try to make things that aren't variable. And they aren't. But your physics does exactly that. You're trying to tell me that the photon that goes right next to the surface of the slit and the photon that goes dead down the middle are the same photon. They're doing exactly the same thing. Their experience will be exactly the same. It'll be part of just a random collection. And if there's a 15 to 1 odds that something happens, it's 15 to 1 odds for this one, and it's 15 to 1 odds for this one and this one. And it's completely illogical to think so.
Blue, whatever. But we know what that wavelength is, or what the frequency of that light is. So there's an objective colour there. And it's this mixing of, quantum ideas with the idea of what is subjective and what is objective. I guess that makes this...
Well, I know, but you're doing it. So what's the point? All of your fundamental principles, the Pauli exclusion principle, these are all basically saying you can't have this, you can't violate Heisenberg, you can't do this, you can't do that. You're the one creating this silly verse. Again, superposition just by its very label. I mean, the Pauli exclusion principle is exactly almost the opposite, where it's saying two particles can't be the same particle at the same time, in the sense they can't be in the same place. Quite obviously, right? Maybe everybody could agree that they both can't be in the same place at the same time, but they think that means something. They think that's so fucking important. It's not important. It's like obvious, and again, it doesn't. The fact that soldiers can't stand on exactly the same piece of ground at the same time, okay, does not mean that your waves have to fall apart and that your soldiers can't attack the bad guys and all. They can't climb the barbed wire and they can't do anything because they can't somehow occupy the same space. No, it really doesn't get in their way.
For physicists, so painful to read, but for others who don't have the background in physics, they read this and go, well, he's using lots of big words here. Physicists use those same type of big words. Then, therefore, I don't want to sound too patronising, but there could be an argument. Well, the language there seems to be the language of a physicist, so maybe he's onto something here. And when you couple that with
you couple that with everybody who does every professional physicist who talks about the slit experiments always aggrandizes the story. They never point out that water waves don't duplicate the single slit pattern at all. They don't make an interference pattern with a single slit. So why is the single slit doing it? They never point out that the multi-slit experiment projects images to the locations, right? Coherent images that can't be built out of randomness. You don't deal with any, and then they always bring up detector experiments, and there's none of these detector experiments ever performed. And the place where they should perform it, that is when they're doing their little buckyball bullshit, right? That's the place they should be doing the detector experiment. Never done it.
So, he's coming from left field. He has no training in physics. It's really a neat story. It's a compelling story in terms of the loner really battling against the system to show that he's got a wonderful new out of left field theory.
Right. So he's battling for double woo, and that you're saying, oh, the people shouldn't be battling for double woo, because they don't have enough evidence for that. And yet you're sitting on a big giant pile of woo for which you have really crappy evidence, just so crappy, so weak, so thin, and you jump to these bizarre conclusions, exclusion principles, and Heisenberg uncertainties, and all this other crap that's just that crap. Bent space, time dimensions. I mean, your whole physical description of reality has been woo-waved into wacky bullshit.
Why does it matter? Because no physicist is going to accept this, and he hasn't said anything that's going to make the average reader go and jump off a cliff or do something stupid.
Well, it's kind of silly for you to say no physicist. Now, again, the Al-Kahari guy is aggressively selling, and the Sean Carroll's aggressively selling that there's multiverses created. Like, I can't even describe how many just happened. Trillions and gazillions of them right now.
Does it matter that some people think that maybe a misguided article is accurate?
Because it changes the perception of physics. It changes the perception of the world around us. And my job as a physicist, and everyone's job as a physicist, is to understand the world around us. And moreover, we're funded by the public. The reason we do these videos, the reason we produce papers, is to disseminate our work. To say
right, and so you're such an evil propagandist. You're getting paid to find the truth, not to find a new religion. And I don't see any evidence that any of you are looking for the truth. You're just looking for, you want to write the woo article. The next woo article, you want your name on it.
Look, this is the way the world is. And that's why it hacks off so many physicists, is because it's false. It's just fundamentally wrong. It's like, I don't know, you're a journalist.
Okay, so again, it's just kind of funny that he's describing, it really pisses us off, yet there's no evidence that you've done anything to stop it whatsoever. And, all the mechanisms that are really feeding it, like popularized videos like Dr. Quantum, you don't even say nothing. You don't say a word because all of you really do think that's a reasonable video. That it's a reasonable description of the physical reality of the experiments that have been done. You just describe experiments and you'll say that we've proven, or we've demonstrated, or it demonstrates, or, we did the experiments and there's this entangled particle thing. You're just telling me that you're sure, you're confident. Those experiments have been done. We proved it. You haven't done anything like that.
It's like somebody coming up. You work really, really hard to get the detail of a story and tell that as accurately as possible. And then some, likely in the Daily Mail, journalist comes along and gives a completely distorted version of the facts. It would hack you off. And for physicists, it's not only dangerous from that perspective in terms of the overall public perception. It's also dangerous in terms of how politicians view what's happening. Because politicians who are in many cases don't have a strong scientific background.
Right. Well, we already know this, right? We can logically deduce this. The only reason why LIGO was built is because theoretically it could have some sort of use for the military. And that's it. There was no other reason it was done. All right, should be back. Let's finish up here. I mean, they're just as guilty.
I'll read this and think, oh wow, and if they've got any sort of influence, I guess, on the funding system, on the funding ecosystem, if you want to call it that, then this could direct funding away from something which is a hell of a lot more valuable.
Right, so that's all of what everything's been done, right? I'm saying, obviously you've funded bizarre satellites doing all kinds of things, microwave this, Star Trekking this, all based on technology that's on its face marginal. The whole idea of LIGO, if anybody really understood what LIGO was really doing, they would really kind of be a lot less confident that they're doing what they're claiming to do, which is measure half the distance of a proton when they're sending a beam back and forth between mirrors 1,600 times. I mean, come on. You know, but yeah, what gets funded has to do with other agendas than the truth. And you people that have some capacity to have some control over that at university, you sort of get to choose things a little bit more rationally. Well, why don't you choose to do these fundamental experiments, these elemental experiments, and see if you can prove for a change some of the assertions you're making?
For this type of nonsense. This particular system, you can't, it doesn't work for this system, and it doesn't.
Okay, so anyway. So you even like you did the 3D glass video, you know, and that's just such an interesting one because it's clearly just a transparency is the difference, right? And it's what's it doing? It's phase shifting the light that goes through one side a little extra phase shift. You know, and just how critical that is to what's happening. How do you reconstruct the light again? Because it's the light's still there. It's just been phase shifted. But it hasn't been blocked or stopped or ruined. It's just been phase shifted. It's a little tiny bit broken and you can fix it again, and that's the key. But anyway, they can't do any logic. So anyway, but it is funny, 11,000 likes, but 358 dislikes. Why? Because he's poking at the people who just desperately want to believe you know, our consciousnesses are magical. I mean, in spite of the fact that the world's just getting dumber and sillier with every step, they all think they're magical organisms. You know, they were Cleopatra, and they were everybody great in history. Oh yeah, that's who I was. Oh, this planet is so fucking in trouble. Yuck. Humans suck. God, they suck at being smart. I mean, they're so proud of their big brain. Oh, we have big brains. We're smarter than all the animals. No, you're not. You're so full of shit. It's just it's wasted. Anyway, till the next time.